So here we are, section 3, the last section of chapter 4, Life and the Biosphere, which will be upon biological extinction, looking at the concept of biological extinctions and how life has been affected by that. So at this point, how do we define an extinction? So we, in general, define it as a permanent loss of a species on Earth at this point. So when a species goes extinct, there is no way it can come back to Earth anymore. And in general, it's a natural process. About one species is lost every million years. So, I mean, it's a very small numbers when you think about it, and that's what we call a background extinction. Every species comes at some point to an end. And interestingly, I mean, this is to remember its extinction is permanent. You have, for example, the dodo coming from the Ice Age movie. This dodo has disappeared because of human activity in itself, and we won't be seeing it anymore on the planet, totally extinct at this point. And an interesting point is that from all life that has been evolved on Earth, 99% of the species that have lived on Earth are extinct nowadays. Naturally, okay? Naturally. At the bottom part, you have extinction from species that unfortunately are not natural, caused by human activities. In 2006, we have lost, for example, the Chinese river dolphin and West African black rhino. In 1989, we lost forever the Costa Rica golden toad, and 2002, for example, the Hawaiian crow. So those species are lost forever. So in general, we have this background extinction, one species every 1 million. One species every 1 million years, and that's a number to remember and to understand this background extinction concept. Sometimes we had specific events not happen so frequently that has caused, in fact, more dramatic extinction. Those are called mass extinctions. We define them by a potential loss of about 25 to 95% of all species of the planet totally wiped out by a specific event. That's, of course, one of the main famous one is probably the loss of the dinosaurs, partly due to meteorite, as it's illustrated from the figures below. Also probably linked into, probably happened also at the same time as massive volcanic eruption. And so at this point, I mean, if you are not adapted to this possible change, like those dinosaurs, well, you're seeing, your friends going away and you're dying, and no chance for your species to survive. In general, those extinctions are very dramatic. We'll see it didn't happen so frequently in the past. There is some benefits, however. It's removing lots of species on the surface of the planet. And so it's giving a chance for new species to come to, in fact, evolve and to take the place of the previous one. That help, in fact, for the biodiversity to kind of blooming after that kind of event. But of course, it's taking some time for those species to populate, in fact, the surface of the planet and to take over it. But in general, what we assist to a major bloom of the biodiversity right after a mass extinction. Based on the geological records, we have observed, in fact, 5 mass extinctions over the last 500 million years or 500 million years. You have a figure representing the number of marine families. Okay, it doesn't show anything regarding land. And you have the 5 major extinctions being shown right here in bold line, 1, 2, 3, 4, and 5. As you can see, it's usually during a mass extinction, you have a drop of the number of species, or in this case families, and just after an increase again of biodiversity. And as you can see, in general, the overall is an increase over time of the biodiversity you can observe. So those 5 mass extinctions are, in fact, if we're looking at the geological table, first, in fact, before even speaking about the first mass extinction, we had a major event which was the creation of oxygen in the atmosphere and the release of oxygen in the atmosphere. That was about 2 billion years ago, and that has probably created a huge change in the possible life that was developing over there. We do not have any trace there, but that's one of the major events that the Earth has known. And for us, it doesn't seem to be a big deal, but Earth initially didn't have any oxygen in its atmosphere. Thanks to life developing in the ocean, oxygen was released little by little in the atmosphere, and so animals and plants could, little by little, invade more of the ocean and more of the land, thanks to the apparition of the oxygen on the atmosphere. Going back to mass extinction, the first one that happened was about 500 million years ago, so during what is called the Ordovician extinction, followed after by another one of about 150 million years after, called the Devonian extinction, followed by the worst ever happened by the Permian extinction. Close to 95% of the species are estimated to have disappeared, between around 90% in fact of the species, followed by the Triassic around 180 million years ago, and finally the most famous one, 65 million years ago, the KT extinction, or Cretaceous tertiary extinction, where the dinosaurs all disappeared. And finally, it looks like, unfortunately, I mean, what I'm asking you to remember is that we had 5 mass extinctions, okay, and try to remember at least one name. Permian is definitely known as the most terrible one, even though Cretaceous or KT extinction is the most famous one due to the dinosaurs. But we had 5 mass extinctions, and it seems that human has started, unfortunately, a 6th mass extinction that we are calling for now the Holocene extinction or Anthropocene extinction, due to the fact that we are entering the period, the era of human, for Anthropos, human. How do we know that? Well, if we look at the geological record, we were speaking about background extinction. And so this background extinction for marine species and mammals living on Earth were showing that we had about 1 species being lost every 1 million years, or that's more or less what we had in general, on average, for the loss. That was the long-term extinction rate or background. Recently, up to a very recent past, what we observe is that extinction went accelerated by about 1,000 times higher than the background extinction. And what we're expecting, and that's concerning mammals, birds, amphibians, and marine species included too. At that point, what we predict for the future is a possible extinction rate that go even 10 times higher than the very recent time. So that means that probably regarding, if we compare to a background extinction, the human caused extinction would probably make disappearing on the planet species at about 10,000 times, at a rate 10,000 times faster than the background extinction. So it's a very, very important concern, and it's happening very quickly. If we look at the time interval, species, biodiversity looked okay most of our time on the planet, except since we have started the Industrial Revolution. With the progress of our technology and population growth, we have impacted massively on the impact, and you can see that the extinction rate of most of the species on Earth is just going way above the background extinction. So that's definitely a very huge concern. At this point, how do we classify in some way the priority on the species to protect? We mostly have two categories. When species goes towards extinction, we first talk about threatened or vulnerable species. In this case, we still have enough individuals for the species to survive. The number of the size of the population is going down, and if we do not take care, at some point, that species will be close to extinction. It will become what we call endangered. That's a case. Examples are polar bears, giant panda, sea turtle. The other category that is close to extinction is what we call endangered species. At this point, you have very little individual to possibly survive. If there is no extra priority care, the species will soon go into extinction. That's the case for some of the tigers, whales, and orangutan that we that are very, very close to extinction, and some of the agencies are trying to protect as much as they can. Looking at where those species tend to be mostly endangered and threatened, here is a map in where we can see, based on the region of the world, where we had most of the species extinct already or those critically endangered. As we can see, we have a huge number of species that are critically endangered, meaning that they are not yet extinct, but if we do not take care of that, they will. And as we can observe, is most of the species being endangered are in fact found in the southern hemisphere a lot, with South America, South Africa, and South Asia and Indonesia itself, also Australia at this point. We had also some species to take care in North America and with Mexico right here, Canada and the US, Europe, for example. What we can see also from this figure is the place on Earth that we have in some way caused the extinction of most of the species is North America, with the colonization of North America by human. We also did quite a lot of damage in Oceania, but most of the species that have disappeared are, for now at least, most of them comes from North America. So a lot of work is due to preserve most of the species. And in general, the first one affected tend to be plants. Plants, fishes, and amphibians are the ones definitely suffering the most from extinctions, followed by reptiles, mammals, and birds. Again, a lot comes from the fact of the geographic distribution. As you go wider, you tend to resist to possible environmental change than when you have a narrow habitats. But in general, we are losing a lot of plants. And again, on the possible over 10 million species that we estimate on the planet, we only know about 2 million. So that's a lot of species that goes extinct without noticing and knowing about it. A few local examples of species being either threatened or endangered. We have the frail shrimp here at UC Merced that is well threatened. The sea otter is threatened along the coast of California, even though its population has grown most recently thanks to some conservation plan protecting this species. And a local fox, the San Joaquin kid fox, is endangered, so very close to extinction, has to be protected. So to end up this video, I'd like just to share this sentence I found from an environmental textbook called Living the Environment, written by George Tyler Miller, saying that within just a few human generations, we shall, in the absence of greatly expanded conservation efforts, impoverish the biosphere to an extent that will persist for at least 2,000 human generations, or 20 times longer than the period since humans emerged as a species. So that means that if we do not prioritize our efforts on conservation and protection, we will destroy the biodiversity and the biosphere on Earth, and it will take more than 200,000 years, probably millions of years, to recover at this point. So when we think about it, that's not really what we hope to, that's not the future we want to provide to our kids. Okay, on this very good note, I hand the session for this chapter 4, and I'll see you in class for chapter 5, talking about conservation, in fact, protection, and threats on biodiversity by humans. Okay, then see you in class. Within just a few human generations, we shall, in the absence of greatly expanded conservation efforts, impoverish the biosphere to an extent that will persist for at least 2,000 human generations, or 20 times longer than the period since humans emerged as a species. So that means that if we do not prioritize our efforts on conservation and protection, we will destroy the biodiversity and the biosphere on Earth, and it will take more than 200,000 years, probably millions of years, to recover at this point. So when we think about it, that's not really what we hope to, that's not the future we want to provide to our kids. Okay, on this very good note, I hand the session for this chapter 4, and I'll see you in class for chapter 5, talking about conservation, in fact, protection, and threats on biodiversity by humans. Okay, see you later. See you in class. Okay, then see you in class.